Hi everyone, welcome to this video. So this is the part 2 of the AWS overview series. So in this series we are trying to cover around 27 AWS services, and we have already covered some services as a part 1. So if you have not watched that video, then please go ahead and watch that video. I'll attach the link in the description as well. And I'll do a quick recap of what all services we have covered in the part 1. So we have already covered VPC, EC2, EBS, EFS, RDS, and auto scaling. So we have already covered these services in part 1. So go ahead and watch it if you have not. Then let's resume the video from here and let's go to the next service, that is Cloudwatch. So now coming back to Cloudwatch. So by now we have set up some instances, RDS instances, EC2 instances, some storage as well. So what will happen if the instance goes down and we are not aware of it? Then we are in trouble. Let's say our instance got terminated due to some error, or there is an issue with the RDS and we are not aware of that. That will be a difficult situation for sure. And we cannot always have somebody looking into the instances. Or if we have a huge architecture or let's say environment with hundreds of EC2, then what is the solution? Nobody, it's very difficult for to monitor manually. So the solution is CloudWatch. It is a monitoring and logging solutions from AWS. So here it observes and monitor your resources, applications on AWS, on premises and on other cloud. So it is not only restricted to AWS, you can monitor it on premises also and other cloud as well. So that is the benefit. So here what it does, it collects some metrics. Metrics, when I say it collects a, let's say CPU disk, if you are running some application, it can collect the data. You can create your custom metrics as well. It does logging also. So it can do all these things. So you can collect the data, you have metrics, and if the metrics is breaching some threshold, you can create alarms on top of it. So that all things you can do. So basically it does data collection, metric and logs from your resources application. Then it monitors, you can visualize the applications and infrastructure with dashboard, you can see. Then you can act, basically you can set up some automatic responses to operational changes with CloudWatch events. So there is something called CloudWatch event that you can do, and auto scaling. So auto scaling we just spoke about, I'll be covering more in the next slide, I would say. And analyze. So you can see it can collect data up to the granularity of 1 second. That is huge. So with this, you can have application monitoring, you can have system-wide visibility, and you can do resource optimization. But how? Suppose you are saying that your resource utilization of your EC2 instances is not very high. Suppose you have created a instance with 16 GB of memory, or let's say 8 CPUs, but the resources are not utilized or even 50% most of the time. So you can optimize your resources, you can create a lower computers EC2 instance rather than the higher one. So all these things you can do. So in this architecture, you can see that uh, CloudWatch is capable of monitoring all the resources. So EC2 it can monitor RDS, but for auto scaling, it it is doing a very important purpose. Suppose we want to trigger auto scaling on CPU, and if we are saying that if the CPU usage is greater than a certain percent or a number, then start scaling out. So there is a term called scaling out. That means add more instances. Scaling means remove instances. So if the CPU percent or CPU number, we can decide on the unit, but is greater than something, then start scaling out. And if it came back to normal, then scale in. So CloudWatch does the metric collection, and auto scaling can integrate with this and read that value. So there's a close integration between these two. Before going to network load balancer, I would request, if you are liking this content, then do drop a like on this video. and also subscribe to this channel. Next is network load balancer. Again, I'll go a step back here. So here we have created some EC2 instances. So pardon me for my drawing and writing. It's not so good, I know, but please bear with me. So here, let's say we have three instances run and we have application on all these three. So as a user, if I want to connect to the application, then I have to connect to this one. That is fine. I got the result. If somehow this is not running, then I'll not be able to access application because for me, I connect to only this one. Either I have to change the, I would say URL or domain name, anything to this one, then I can start accessing again. But that is not something efficient to do. So again, this instance goes down, then what will happen? Then I have to connect to this one. Or if the new instances are created, then their DNS will change. So in order to solve all this problem, there is a term called load balancer. So that balances the load on these. So but for network load balancer, here it is capable of forwarding traffic such as TCP, UDP, and TLS traffic. So network load balancer works at layer 4 of the OSI model, that is the network layer, and it can forward or load balance the traffic that is of TCP, UDP, and TLS protocols. So it can route traffic to targets such as EC2, instances, containers, and IP address. So you can have all these, and it is capable of handling millions of requests. Now coming back to the previous example, suppose we have added the load balancer here and we have instances. Now if the end user is coming, then he will be accessing the DNS of this thing, that is the NLB, and further NLB will route the traffic to these. So if this instance goes down, that is the possibility still there, but now we have an NLB, so it will not forward traffic to this because it do a health check. Now it will send traffic to these two. So that is the benefit that we get with NLB. But here you can see that ALB as well. So ALB is application load balancer that I'll be covering in a minute or so. So you can see that NLB is capable of forwarding to traffic to other ALB as well. So you can set up a NLB, network load balancer, that can forward traffic to application load balancer, and further application load balancer can forward traffic to EC2 instances. So that is NLB. So how it fits in the design? So you can see that we have created an NLB here. We have EC2 instances, and NLB integrates very well with auto scaling also, or load balancer. Basically ALB or NLB both integrates very well with auto scaling, and it creates a very good use case. I'll explain. So we have seen what auto scaling is. I'll not cover that again. We have three instances. We have auto scaling here. This is covered, but now we have NLB. So as I said, if NLB is routing traffic to these three, if this instance goes down, then it will route to these two. If this goes down, then it will route to this. But if we add auto scaling here, then auto scaling, what it does, if this instance goes down, then auto scaling will bring in a new one. If this goes down, then auto scaling will bring a new one. So with auto scaling, we always have three instances running all the time. So that means the performance is not at all impacted. So that is the combination of NLB and ALB. So if we have defined the desired capacity or the maximum capacity or minimum capacity, we can define these. But auto scaling with us, if some instance goes down or unhealthy, then it will create a new one. So that is the benefit with NLB and auto scaling. Next is application load balancer. ALB is capable of forwarding HTTP and HTTPS traffic, and it works on layer 7 of OSI model. It can route traffic to EC2 instances, container IPs, and Lambda functions as well. Lambda we'll see in some time. And it is capable of doing content-based routing. So you can forward traffic on the EC2 instances based on the particular content or some of the fields that are coming in the header. So based on that, you can forward traffic from application load balancer. Lambda function, HTTP, HTTPS traffic. Again, we have uh, application load balancer that is talking to forwarding traffic to EC2 instances. And similar to NLB, it is also capable of integrating with auto scaling, and it again offers the same benefit. So the next service is Route 53. So I have added this as a networking, but that can be decided like if somebody is placing on the different category. But Route 53 basically does three main functions: domain registration, you can register your domains; DNS routing, and health checks. So these are the three main functions that Route 53 do, and it helps in routing the end user request to the internet application. It is a highly available and scalable domain name system web service. So how it works in a very simple way, suppose end user is trying to access the endpoint instances that are in AWS, and they cannot access it directly for sure because we have not allowed. So what it does, it goes to DNS, they access the domain name. So it goes to DNS resolver, it resolves the domain name and sends the request to DNS service. From here, it returns the IP address of the endpoint instance, and then it does a health check whether the application or the prefix that it is trying to access is accessible. If it is healthy, then it returns a response to the user, else there will be some error. So that is how Route 53 works. In Route 53, you can create some hosted zone, you can create alias records, A records, you can do all these things in Route 53. So the placement is like this. So here we have placed this Route 53 on top of our load balancers, and a user can access a Route 53 um, DNS, and then that is mapped to our load balancer, and further load balancer is forwarding the traffic to instances. So that is how Route 53 works. S3. So S3 is one of the foundational service and most widely used service, I would like to say. S3 is simple storage service, and it is directly indirectly is being used at many places in AWS. So first of all, this is a object storage service. It can store and protect any amount of data virtually. It is highly scalable, highly available, security and performance. It offers great security and performance as well. You can store any amount of data, I already said. So you can see that we can store any analytical data, log files, application data, video, pictures, backup, any kind of data in S3. You can create buckets in S3. You can store data in S3. But just one point to highlight, the bucket names are global. So if you are trying to create a bucket with name test, and if that name is already taken across AWS globally, then you will not be able to create. So buckets name are global, that you need to consider. You can store the data here. So you can see the cost optimization thing, because you can choose your storage class like intelligent tiering or glacier or standard storage. All these things are there. Then you can control access to the data via IAM policies or S3 bucket policies. You can do cross-region after application. You can do a lot of things with S3. So once you have data, then you can do a analysis on that data. Basically, S3 is a storage service. So here, what we are doing, we are allowing our EC2 instances to read some data from S3 that they can do. And we already have seen Cloudwatch. So Cloudwatch logs can be easily exported to S3. They can be stored and then further analyzed. So S3 plays a critical role here. Coming to the next service, that is Lambda. So far, we have seen that we are hosting an application. Uh, for that, we have to create some uh, EC2 instances. We have to install that application and we have to set up the environment, runtime environment. We have to do all these things. But what if we want to run a simple code many times a day? Then do we need to create EC2 instances all the time? Or if it's just a small code that do quick processing? Something like that. So for that purpose, what we have Lambda. Here you can run your code without provisioning and managing servers. So this is a serverless offering. Here you do not need to create these instances or anything. You just bring your code and it supports Node.js, Python, Go, Java, and some more languages. So let's say you have your Python code that you want to run maybe 50 times a day. So you can just create Lambda and schedule it. It will run 50 times that Python code and you can store the results in S3 or anywhere you want. Like so that is Lambda. So it is a serverless service and it is a very quick to deploy. You have to just bring the code. So an example here, suppose a photograph is taken and that photograph is uploaded to S3. So there is a close integration between S3 and Lambda. So as soon as the object is uploaded in S3, a Lambda is triggered and that Lambda has, for example, it's a Python code that do some processing or resizing of the photo and then store back. So here Lambda, so it can read and write from S3. It can pick some data. Let's say there is some analytical data available in S3 and you want to do some analysis and find some conclusion out of it. So you can create a Lambda function that can read from S3, do some analysis and store back here. But there is one thing which is very important that needs to be considered with Lambda, that it can have the maximum runtime of 900 seconds, sorry, or 15 minutes. You can have that maximum. So in case you see that the function you are running that can take more than that, so it will time out. So better to break it into multiple lambdas. If that is not feasible, then you have to install your application on EC2 instances, or there is one more offering that I'll be covering, that is Elastic Beanstalk. And there are some more servers, but I'll be covering these three only. In case this video is helping you in understanding the AWS services, then do press the like button and also subscribe to this channel. Thank you. Next is IAM. That is, I would say, the heart of all the services because it controls the access management. So this is the identity and access management service. So what it does? So we have seen that we have we have EC2 instances, we have created RDS. Is it like that EC2 instance can directly talk to RDS without any permissions? Or we have also seen Lambda functions and we have seen S3. Is it like that a Lambda can directly access S3 data without any permission requirement? If that is the case, then there will not be any controls mechanism in place. But ideally, that is not what happens in AWS. So in order to talk between these, there is a service called IAM and they need to get authenticated from IAM only. So in IAM, we create users, roles, policies, all these things we create. So if I just talk about this use case here, we need to create some roles. Let's say we created a role here that has permission for RDS. So we attach this role to EC2 instances that in the form of instance profile. Now EC2 has instance profile with RDS permission. So now it can read that. Same case with Lambda. We create an IAM role here, will attach to Lambda so that if Lambda tries to access S3, then that role should allow it. So that is how the inter-service communication happens. This is service role that we call it. So roles has policies attached to it. Policies and policies basically are permissions, like what they can do on what resources. So identity access management, this is who, users, can access permissions and what? These are the resources. Let's say you can control fine-grained permissions, like you can say Lambda, you can only access S3, this is bucket ABC, and you can perform only restricted action on that. So up to that granularity, you can control the permission. So this is the IAM. So here we can see that in order to talk to RDS, first EC2 need to have permission from IAM role. And same case with Lambda. If we wanted to talk to S3, then it has to have permission in the form of roles assigned to it that will allow access to S3. So IAM itself is a huge topic, and we should always follow the principle of least privilege so that we should allow what is required, not more than that. So before moving to the next service, that is AWS Secrets Manager, I'll take a pause here, and I'll be releasing rest of the services as a part 3 of this AWS overview series. So if you like the video, then do press the like button and also subscribe to the channel. Thank you for watching this video.